Hey beautiful minds, welcome back to Gen Z Learning, and in this video we will be learning the chapter Newton's laws of motions. So let's begin. General concept of force. Now we all know what force is. Force is nothing but external effort in the form of a push or pull which either changes or tends to change the state of rest or the uniform motion of a body along a straight line. Now we have two types of forces, contact forces and non-contact forces. Contact forces are basically the forces which occur due to contact between two bodies. For example, frictional force, tensile force and non-reaction. Whereas non-contact forces are the forces which occur without any contact between the two bodies. For example, field forces. Let's look into the concept of inertia. Inertia is the inherent property of all the objects that they do not change their state of rest or of uniform motion along a straight line path unless acted upon by a force. There are three types of inertia: inertia of rest, inertia of motion, and inertia of direction. Inertia of rest is the inability of a body not to change by itself its position of rest. For example, when a bus or a train starts suddenly, a passenger standing inside it leans backwards due to the force exerted by the bus or the vehicle. Whereas inertia of motion is the inability of a body not to change by itself its state of uniform motion along a straight line. For example, when a vehicle stops suddenly, a passenger standing in it leans forward. And inertia of direction is the inability of the body by virtue of which it tries to resist a change in its direction of motion. For example, when a bus suddenly turns towards right, the passengers lean towards left. Let's look into the Newton's first law of motion. An object at rest tends to stay at rest and an object in motion tends to stay in motion with same speed in the same direction unless it is compelled by some external unbalanced force to change that state. For example, when we apply a force to a ball, then its state changes from rest to motion, and vice versa if we stop the moving ball. But if we apply no force to the ball, then there is no change of state. Let's look into the Newton's second law of motion. The rate of change of momentum of a body is directly proportional to the applied force, and this change takes place in the direction of the applied force. That is, delta P by delta T is directly proportional to F. Now let's look into the proof for F is equal to ma. We know that momentum is defined as the product of mass and velocity, that is P is equal to mv. Now let us consider a body of mass m moving with an initial velocity v. Let F be the force applied on it for a time delta t. Due to this force, the velocity has changed from v to v plus delta v. So the initial momentum is mv and the final momentum is m into v plus delta v. So the change in momentum will be equal to final momentum minus initial momentum. That is m into v plus delta v minus mv. The change in momentum here is delta p, and here we multiply the m inside and get delta p is equal to mv plus m delta v minus mv. Now we cancel out the plus mv and minus mv and get delta p is equal to m delta v. Now dividing delta p and delta v by delta t, we get delta p by delta t is equal to m delta v by delta t. But delta p by delta t is directly proportional to F. We know this from Newton's second law of motion, and delta v by delta t is acceleration. So we get F is directly proportional to ma. Now we replace the directly proportional symbol with a constant k and get F is equal to kma. For convenience, take the value of k as 1. Then we get F is equal to ma. Hence proved. Next topic is Newton's third law of motion, law of action-reaction. It states that to every action there is an equal and opposite reaction. For example, a body A exerts a force FAB on body B, and body B exerts a force FBA on body A. The addition of these two forces will give us 0 because they are equal and opposite, and plus and minus gives 0. We can also write it as FAB is equal to minus FBA. The next topic is Newton's second law is the real law of motion. Why is it so? It is because both first law and the third law can be derived by the second law. And now, how is Newton's first law of motion is derived by the second law of motion? Let an external force F be acted upon on a body of mass m, and if the acceleration produced in the body is a, then from Newton's second law of motion we know that F is equal to ma. Now if we assume that F is equal to 0, then acceleration will also be equal to 0, but mass will not be equal to 0. This basically means that in absence of force, there will be no acceleration. That is, the body will not change its state of rest, basically maintaining its original state, which is clearly Newton's first law. Now, how is third law derived by the second law? We know that F is directly proportional to dp by dt by the second law. Replacing directly proportional symbol with a constant, we get the value of k here is 1, so we don't have to write it. Now the rate of change of momentum for this force will be dpb by dt, and for this it will be dpa by dt. Adding both the forces, we get FAB plus FBA is equal to dpb by dt plus dpa by dt. Taking d by dt common here, we get FAB plus FBA is equal to d by dt PB plus PA. Here P is the total, and as per second law, P is concerned, which is basically constant. We get FAB plus FBA is equal to 0. Equalizing the forces, we get FAB equal to minus FBA. Hence proved. The next topic is law of conservation of linear momentum. This is before collision where u1 is greater than u2 with masses m1 and m2 and velocities u1 and u2. This is during collision with masses m1 and m2 with forces F12 and F21. And this is after collision with masses m1 and m2 with velocities v1 and v2. Also remember that F12 is equal to FAB and F21 is equal to FBA. Anything works. Therefore, initial momentum of m1 is equal to m1 u1. Initial momentum of m2 is equal to m2 u2. Final momentum of m1 is equal to m1 v1. And final momentum of m2 is equal to m2 v2. We know that force is equal to change in momentum by time interval. So F12 is equal to change in momentum produced in mass m2 by collision time. Change in momentum here is final momentum minus initial momentum of m2's. We get F12 is equal to m2 v2 minus m2 u2 by t. Also it will be delta t here because collision time is very small. Similarly, for F21, which is equal to change in momentum produced in mass m1 by collision time, we get F21 is equal to m1 v1 minus m1 u1 by delta t. From Newton's third law, which is F12 is equal to minus F21, we get, using these values, m2 v2 minus m2 u2 by delta t equal to minus m1 v1 minus m1 u1 by delta t. Cancelling out the delta t's, we get m2 v2 minus m2 u2 equal to minus m1 v1 plus m1 u1. Getting rid of the minus signs by shifting, we get m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. that is total momentum before collision equal to total momentum after collision, which basically answers the statement of law of conservation of linear momentum, which states that total momentum before collision is equal to the total momentum after collision, provided no external force acts on the system. Hence proved. Let's look into an example of law of conservation of linear momentum. According to law of conservation of momentum, total momentum of the gun and the bullet before firing and the total momentum after firing will be equal. That is, total momentum before firing is equal to 0 plus 0, which is 0. Total momentum after firing is equal to mv plus mv. Here capital MV is referring to the gun. The small mv is referring to the bullet. According to law of conservation of momentum, 0 is equal to mv plus mv. So we get mv is equal to minus mv. V is equal to minus mv by m. Usually they will ask you for the velocity of the gun in most of the questions, but just remember this formula, the rest will be done. Congrats guys, we've reached the end of the chapter. Hope you liked this session. Hit the subscribe button for more such videos.